here using their phones, so hopefully this will be all right. All right, so what we're really going to be doing is doing your homework, some of it. So we're going to do one or a couple of each section. But the 3.6 notes that we had done the day before, you were given a problem and you had to do it all three different ways. So the quadratic formula, completing the square with those square roots, and then factoring. Sometimes you couldn't factor, but if we could, we were doing it all three ways that we've been spending a lot of time on. The homework then breaks these up. So in the homework, these directions are simply solve the quadratic equation by factoring. So 1 through 6, those should all factor nicely. We can use the other methods if we wanted, but right now, 1 through 6 is simply factoring. 7, 8, 9, 10, 11, and 12, we're completing the square. You're only going to do those by completing the square. And some of those I'm not even going to have you do. And then the last 4 were with the quadratic formula. So we're going to do these in isolation as a little review. And then 3.7 then kind of gets into now, instead of me making you do all 3 methods or doing them in isolation like this, here's a problem, you're going to pick the best method. That's sort of what the next section is. So before we dove into that, I just thought it was good as a little review to do these. Let's review some of these factoring methods, and then you'll do this, finish this for the homework, and then hopefully we're good to go into tomorrow. We'll hopefully have a quiz by the end of the week. We don't have a regular school day on Wednesday, which hopefully your advisory teacher has informed you. You guys all have that thing going on Wednesday. So we'll probably quiz hopefully the end of the week on a Friday. And then we're getting close to the end of this module to where we could then take a test over the module, okay? Your packet should be getting pretty thin as you start to go through those. So page 21, let's go ahead and get going on these. And we're gonna solve these by factoring. I'm just gonna have you start with number 2. So if you jump to number 2, because number 2 is what the most common type of factoring problem that we've been doing. It's one that hopefully we can look at and do pretty quickly because it's a trinomial with a coefficient of 1. That's what we've seen the most. So that should be what we're the best at. When we did these trinomials with a coefficient of 1, what we would understand hopefully is when we go to factor this, the only way that we can get an x squared is if the both first terms, got the wrong pen, give me a minute to get one that works, is if the first terms were both x's. So this x times this x would give us the x squared. And then now we kind of get into the little math numbers where you're trying to figure out what numbers multiply to be that 24. There's a lot of ways to get 24, 1 and 24. So like 1 times 24, 2 times a 12, 3 times an 8, 4 times a 6, that's about it. Those all give you 24, but we want the one that's going to add up to be a 10, and that would have to be that 4 and the 6. So we can write that as x plus a 4, x plus a 6. From there, we can go ahead, when we did these, notice how it said equal to a 0. So what we just looked for is what number would have made this factor a 0, and that would be a -4. And then we do the same thing with the second factor. We look at the second factor here and just identify what number is going to make that x value into a 0, and that would have to be a -6. So we get 2 answers, -4, -6. If we were to take these values, plug them into the original equation here, then it's going to make the left-hand side equal to a 0. All right, that should be the method that we've done the most recently because we do the quadratic formula with that. We've done the completing square with that. However, let's say we have a binomial. So let's go binomial like number 1, number 4. Notice how there's only 2 terms in those. I think there's one more. Yeah, number 5. There's only 2 terms in those. If you're told to factor and there's only 2 terms, we can't do it the way that we just did it. All right, so we have to kind of recall some of these old methods. So when we factor, in general, really, one of the first things we want to look for always is a greatest common factor. So we really could have looked for that in this first one. So what that means now is, if you recall, if I look at all 3 of the numbers in this first problem, a 1, a 10, and a 24, the only common factor of that would have been a 1. So it's a waste of time for us to worry about that. But we do want to look for that first and foremost, just in case that were to pop up. So if we go down to number 4, so go to number 4 real quick. If we look at this term here, and then this term here. And if I ask you if there's a greatest common factor, there is now a greatest common factor. And it's not a 1. There is a 1, so like a 1 and a 6. You could put 1, but typically that means we don't want to have to deal with it. But notice how this had 2 x's and this had 1 x's. So when we were dealing with the variables, we were asking ourselves, all right, what's the most common number of x's in both terms? They each have 1 x in common. So we do have a greatest common factor of x. And when we did that, we basically said we're going to undistribute. We're going to kind of do the opposite of distributing, where I'm going to take these two terms and I'm going to pull out an x from both of those. So if I pull out an x from both, I initially had 2 x's in this first term, so now I'd only have 1 x left over for the first term, plus, and then if I had a 6 with an x initially, but that x got pulled out, then the only thing left over here would be a 6. So if we have a greatest common factor, that's really our first option. We want to just pull that thing out. When we now look at this, this here should now look similar to the 2 that we just did up here. So what we now want to do is ask ourselves, what number makes this factor equal 0? And that's got to be a -6. But we also have that single x out in front. So if I go here, what number is going to make that equal 0? Well, if it's just the variable x, the only thing that could make that equal to a 0 is 0. So those end up being our two different answers. Recall we actually did this the first time or two. I said take this factor, set that equal to 0. Take this factor, set that equal to 0. And we actually went through the steps to solve this. So that's why one of the answers is a -6, but isn't the other one just right away an answer x equals a 0? All right. So we do want to look for a greatest common factor if that's possible. Now, when we go up to number 1, it's a binomial again. Again, we'd want to look, is there a greatest common factor by any chance? So if we look at a 1x squared, so between the 1 and the 9, there's only a 1 that's a common factor. Do they each have at least one variable? Does the 9 have a variable? No. So there is no greatest common factor here. I shouldn't say that. The only greatest common factor is a 1. And if that's your only greatest common factor, it doesn't do us any good. So what we then called, and again, we didn't do a ton of these. So the first thing we look for when we do a binomial is the greatest common factor. The second thing we look for is if this is what we called a difference of perfect squares. So we just did these a handful of times. It's now been a while since we started doing the quadratic formula, and we started completing the square with square roots. But notice how if we look at these one more time, this is a difference. So understand what that means. It's a subtraction problem. So that's a subtraction problem. And what we need to be subtracting are two perfect squares. So x squared is a perfect square, and then 9 is a perfect square. So the way that that factored, the x squared could again only be gotten by an x and an x. But then if you remember, we thought about what did I square to get a 9? It had to be a 3. So each of these has to be a 3. And then we talked about how one of them has to be a sum, one of them had to be a difference. That's how we factor a difference of perfect squares. And once that's factored, now we can do the same thing we've done in the previous couple of questions. The x value of a -3 is going to solve that one to 0. And for the second one here, the x value of a +3 is going to make that one into a 0. All right. So real quick, just since that's the first time we've seen one of those in a number of weeks, let's say I had you factor x squared minus 25. That's a difference of squares. The x squared could only be gotten from x and x. And since that's a difference of perfect squares, these both have to be 5s. One is a sum, one is a difference. And that's how we factor a difference of squares. It's very easy. We just haven't done it in probably 3 or 4 weeks. All right, and we didn't do a ton of them when we did. So that's how we handle those binomials. All right, the rest of these I'm going to leave you, at least for the factoring problem. So now jump down to the bottom. Because now these, it says solve each quadratic by completing the square. And these, we're going to not do all of these. Let me see which ones I wanted you to do. Yeah, so here's the ones I'm going to have you not bother with. So cross out 7. I'm not going to make you do that. I'm not going to make you do 8. So go to number 9. So this one does factor. So if you were given an option, this does factor. So don't do this right now because this isn't how we're going to do it. If you do the homework, we want to do this the way you're told. This is by completing the square. But I could factor this to be x plus 9 and x plus 5. 9 and 5 multiply to be 45. A 9 and a 5 add up to be a 14. So if you could factor it, if that was an option, I think factoring is the best bet if it does factor. You were told to do this by completing the square though. All right. So the way we did that is we took the x squared and the 14x and we made a perfect square out of that. And then what we adjust that 45 at the end. So think back when we did those squares. If I had 14 x's, I would have put 7x in this corner, 7x in this corner. This would have been our x squared. So we would have had an x plus a 7 on the side, an x plus a 7 across the top. So a 49 would have made this a perfect square. All right, that would have been what we would have had to have had. So that's what we add to make it a perfect square. Let me leave a little bit of space because then if I added 49 inside, we'd have to subtract the 49 from the 45. If we look at our square, we have an x plus 7 and an x plus a 7. So this just becomes x plus 7 squared. And then 45 minus 49 is a negative 4, and then that would equal a 0. Completing the square now, the way we actually, once we have done that, the way we solve that is with our square roots. So this is now where we want to get this by itself, so we want to isolate this squared term. So I'm going to add 4 to both sides to get rid of the 4. So those will cancel. Once we've done that, that's when we used our square root. So now I do the square root of the left-hand side to get us just an x plus a 7. And if I do that to the left-hand side, I've got to do that to the right-hand side. So I also do the square root of a 4. And we know we should get a positive and a negative square root of 4. So it's actually a positive and a negative 2. Then we treat the first equation as if this is a positive 2. So I could do x plus 7. Let me do it elsewhere so I have a little bit of space to work with. So one of these would be x plus 7 equaling a positive 2. And then the other one, we treat this as if R2 was a negative 2. So we do x plus 7 equals a negative 2. And then we just solve this equation, solve this equation. Those should be our 2 different answers. All right. So for the first one, if I subtract 5 from both sides, not 5, sorry. I'm thinking ahead a step there. Subtract 7 from both sides, we should get a negative 5. So that's one of our answers. And then if I subtract 7 from both sides, negative 2, negative 7 make a negative 9. All right. Think back to when this factored, right? We said this could have been x plus 9, x plus 5. Doesn't a negative 9 make this a 0? And a negative 5 make this a 0? Those, not coincidentally, were our 2 answers, a negative 5 and a negative 9. All right. All right. Yeah, let's do one more of these. So number 10, do that first step, because again, this is what I want to make sure we remember how to do. Do the first step here with completing the square. This one I don't think does factor, so factoring wouldn't do us any good here. All right, and then let's see if we got that first step done. If you still need to do your little boxes, feel free. The middle term here, if we would have had 8 x's, then you would have put 4 of them here, 4 of them here, and this obviously had to be x squared, so you would have had an x plus a 4 on the top and the bottom. So to make that a perfect square, you would have had 4 times 4. So we should have been adding 16 inside, we would have been subtracting 16 on the outside. This then becomes an x plus a 4 times an x plus a 4, so x plus 4 squared. And what is that? Negative 54 set equal to a 0. From here, it's now kind of the same steps. We want to move this 54 to the other side. So I'm going to do that by adding it over. So that our x plus a 4 squared equals 54. Take your square root to get an x plus a 4. But then recall I said this doesn't factor. Because it doesn't factor, that means you're going to get kind of an ugly number over here now. You're not going to get a nice perfect square like we did earlier. So this now becomes a plus or a minus. And then think about if we can simplify a root 54. Yeah, think about that one myself. Yeah, and we definitely can. Wow, Christian. It's dedication though, Christian. I appreciate you trying to log in while you're on a plane. That's good. All right, so the 54, then we need to try to break this down. So we want to come up with 2 numbers that multiply to be 54. And again, only worry about your perfect squares, 1, 4, 9, 16, 25. Only divide those numbers into 54. So the 1 we don't really ever need to worry about. The 4 doesn't go in evenly. If we do a 9 though, 9 should go into 54 evenly, correct? That should be 9 times 6 should give us 54. So let's simplify that first. So we'll get plus or a minus 3 root 6. Then, just like we did in the previous problem, we want to treat, if we go to set up our equations right now, I'm going to do them over here. I'm going to do x plus 4 equals, and the first one I'm going to do it as if this is a positive 3 root 6. So I'm going to set it equal to a positive 3 root 6. And then the second equation that you're going to set up is if we treat that 3 as if it was a negative 3 root 6. So we do x plus a 4 equals a negative 3 root 6. Solve these. So subtract a 4 from both sides. Since these are not like terms, it's just going to look weird. You just get a 3 root 6 minus a 4. That's one of our answers. Subtract 4 in the other equation as well. Those will cancel. And then we get a negative 3 root 6 minus a 4. That's our second answer. So again, if it factors, you get nice numbers like number 9. If it doesn't factor, you're going to get these weird irrational answers that have the radicals involved. All right. All right. So that's those. You're not going to worry about number 12, but when you do the homework, you should have number 11 done. So 11, I'm going to leave you to do on your own. And then we'll do 1 or 2 of these guys. And then just make sure then after that, you have 1 through 16 all done. All right. So number 13, this we got to be pretty good at. This we've been spending a ton of time on the quadratic formula here. This we got to be pretty good at. I don't need to write it. Here's our quadratic formula there. So we got that on our paper. So we now go to plug in all of these. If I want the opposite of b, well, let's label all of them first. Let's make sure we got that part. Our A has to be the 5, as long as it's in standard form, which this is. Our B has to be this 1. And then the C needs to be -4. So if we now go ahead, solve this for x, then we want the opposite of B. So our B is a +1, so this should be a -1. Let me erase all this so we can see where we're getting all this. So this is the opposite of B, and then now I'm going to do the B squared underneath the radical. So that's 1 squared. And then -4, and then whatever A is, whatever C is, get multiplied by that -4. So that's a 5 and a -4. All divided by 2 times A. Our A is a 5. So from there, we have our -1 plus or minus. 1 squared is a 1. And then here's where you just need to be careful. When we eventually get to a quiz on this, this is where we tend to mess up. -4 multiplied by 5 should be a -20. So these first two numbers give us a -20. But when we take that -20 and multiply it by a -4, that should give us a positive and then 80. All of that gets divided by 2 times 5, which is a 10. So -1 plus minus square root of 1 plus 80 is 81 divided by 10. So we actually get a nice number here. Because square root of 81 is a perfect square of 9. All over 10. But if you remember, that little plus minus means we again get two different solutions. So just like we did above, we're going to do one of these as if it's a +9, and then our other answer is going to come from us saying that it's a -1 minus 9. And then that's how we should get our two different solutions. So the first one, -1 plus 10, or -1 plus 9 is 8 over 10. That would reduce down to be 4/5. That's not a 5. So that's one answer. And the other one ends up being a nice number. -10 divided by 10, our other solution would have been a -1. All right, yeah, Cam?
For the first solution, you don't want decimals, right? So we should put the correction.
I don't want decimals if there's a square root involved. All right, if there's a square root involved, I want the exact answer, because it's like the square root of 5. I don't know what it is off the top of my head, but it's 2.2 something that goes on forever and ever and ever. It's irrational. So this is exact. If you give me root 5, that's considered an exact answer. You're going to have to round this at some point. And if you just give me 2.2, this is now not exact. And that's our issue. Like, we want the exact answer, not the rounded answer. 4/5 and 0.8, these are both exact answers. So since these are both exact, I don't necessarily care if it's a fraction or a decimal, since both of these are just different ways of giving me the exact answer. When we have to round an irrational number, we don't want to be doing that. All right?
Okay.
Unless you're told to.
Yeah.
All right. All right. And then one more of these I want to do. We'll do 15 and or 16 or 16. Let's do 16. So go to number 16. And the reason I wanted to do one of these two, what you have to make sure of first and foremost, if you're going to do the quadratic formula, right? So the quadratic formula is what you're told to do here. You have to make sure that your equation is set equal to 0. So number 13, that was already done for us. Number 14, that is already done for us. But if you look at the last two, you need to make sure that these are set equal to 0. Right now it's set equal to 6 on this side, and on this side we have both terms over here. So in order to make this happen, what we want to do is we need to take this 2x, move it over. We need to take the 21 and move it to the other side. So to do that, I'm going to subtract 2x from both sides. So that would give me a 5x squared minus 2x would now equal a 21, but don't we still need to move that 21 over? So now I'm going to subtract 21 from both sides. So in standard form, this is 5x squared minus 2x minus 21, and then that equals 0. Now that this is equal to 0, now we can go ahead and do the quadratic formula. So number 15, we won't go all the way through it, at least we won't right now, but you need to do it for homework. Just understand what needs to be done first and foremost in number 15. That 6 better get moved over to the other side first. Then you can go through with the quadratic formula. Okay? So then from there, now we can identify our A, B, and our C. A is a positive 5, B ends up being a negative 2, and then C ends up being a negative 21. So if we don't want to come up with these values up here, because you would have thought that maybe B was a positive 2 and C was a positive 21, they're not. It should be negative and negative. All right. And if you understand that, then it's the same thing now that we just did above. So we want the opposite of B. We now know that our B was a negative 2. So when we plug it in, opposite of B would be a positive 2. Plus minus B squared, and then minus 4 times A times C. A is a 5, C is a negative 21. And then all divided by twice A. Ooh, it's going to be a big number. I might need some calculator help there. All right, so the next step, we do 2 plus or minus. Negative 2 squared should be a positive 4. Then the negative 4 and 5 make a negative 20. And then I'm going to take a negative 20 and multiply it by negative 21. So what is that? 420?
Yeah, that's correct.
Yeah, thank you. So 420, all divided by 10. So from there, 2 plus minus the square root of 424 divided by 10. Oh boy. 4. I don't even have my... All right, so now what we want to do, I'm pretty sure 424 is not a perfect square. So find two numbers that multiply to be 424. So somebody see if they can do that while I get my calculator here.
Does 106 and 4 work?
Say that one more time.
106 and 4.
Yeah, I think 4 will definitely work. The question will be 106 is 53. Yeah, that's all we're going to be able to do. Yes, thank you, Ahmed. 106. Yeah, 106 is a pretty big number. You may think you can break that down further. You really won't be able to, because that would be 2 and 53. 2 is a prime number, 53 is a prime number, so that's all we're going to be able to do here. So 2 plus or a minus the square root of 4. The reason we picked that is because it was a nice perfect square. Let me try to squeeze this in. So that is now 2 root 106 divided by 10. And then recall how we now wrote this when we were doing these in quadratic formula with this irrational number. All we really, if you gave me this answer, I would take it. This is fine when it's irrational. That's a legitimate way to write this answer. But we also talked about how if this can be reduced, if it's multiple choice, I would have you reduce those. All three of those are divisible by a 2. So if I took this 2 and divided by 2, that's a 1. Same here, 2 divided by 2 is a 1, and then root 106. And then if I took 10 and divided it by 2, it would give me a 5. All right. So a little review of everything that we have been doing here the last 2 weeks probably on all of these. What you are now going to do, and you should have a bunch of these now done, so no reason not to get this turned in. is your homework is to finish 1 through 16. And then keeping in mind, I don't need you to do the completing of the square root method with 7, 8, and 12. So you can cross those out and not worry about those. All right. So this is the homework. Get that done. It'll be due again tomorrow by the end of the day. If you have any questions, check in with us second period tomorrow, and we can help you out with any of the stuff. All right. All right. Good seeing everybody again. We'll see you tomorrow. If you have any questions, you got a couple minutes here. Hang out and let us know. All right. All right. See you guys.
Yeah.
Say that again, Sally.
Lots of today.
What was Wednesday? You said in the beginning of class there was something happening Wednesday.